In today's lesson, we're going to review how to solve systems of equations by graphing. For some of you, you need only a little bit of review, in which case I suggest that you just listen for the steps, then pause the video, try problems 1 and 2 on your own, and then fast forward to the solutions. If you get them correct, move on to 3 and 4. If you don't, then rewind and listen to the steps to identify your mistakes. To solve a system of equations by graphing, it's important that we identify that we have to solve each equation for y only if necessary. I want my equations to be in slope-intercept form, just like I see in number 1. Okay, so in example number 1, I wouldn't need to solve because y is already by itself in both equations. In example 2, I would need to solve for y first before graphing. Okay, so I'm going to solve for y if necessary, okay, and then I'm going to identify the coordinates of the point of intersection. So my answer is that point of intersection that I'm trying to find. So let's begin with our first equation. It's in slope-intercept form, so I'm going to start with my y-intercept of 3, up 3, and from there I'm going to count up 1 and to the right 2, up 1 and to the right 2, as many times as I can. And then I'm going to reverse the process down 1 and to the left 2 so that I can be as accurate as possible in my graphing. The more points that I can get, the better. Okay, so I'm going to connect these all the way across with a straight line. Okay, and now I'm going to graph my second equation. I'm going to use a different color just to represent that I'm going to do this is a second equation. I'm going to start up at my y-intercept of 4. From there I'm going to count a slope. I don't see it, but it's a slope of 1. So it's a slope of up 1 into the right 1. So I'm going to do that as many times as possible. And I'm going to reverse it down 1 into the left 1. Okay, and I'm going to connect those with a line that's going to be hopefully as straight as possible. My final answer is this point of intersection. So my final answer is this ordered pair. I need to write that ordered pair. It's written to the left 2 and up 2. So to the left 2 and up 2. So my answer is -2, 2. I have to write it as an ordered pair. And I can check to make sure that this works. If I substitute -2 in for my x coordinate, -2 plus 4, does that give me 2? It does, and therefore it works for this one. If I do -2 in for the x coordinate here, -2 times a half is -1. -1 plus 3 still gives me a y coordinate of 2, so I know that my answer is 100% correct. So final answer, -2, 2. In the second example, our equations are not solved for y, so I need to do that first. I'm going to solve for y by subtracting x and then dividing by -2. So I get y equals positive 1/2 x, and then -1. I'm going to graph that by starting at the y-intercept of -1, and from there counting up 1 into the right 2. and then reversing that by going down 1 and to the left 2. And I'm going to connect these points with as straight a line as possible. I'm going to change colors just to indicate that I'm now solving a different equation. And I'm going to solve this second equation again for y. And I'm going to do that by subtracting x from both sides and dividing by 3. So y equals negative 1/3 x minus 1. So here I'm going to start at negative 1, and I'm going to count down 1 into the right 3. Down 1 into the right 3, down 1 into the right 3, and then reverse it, up 1 into the left 3. And I'm going to connect these with a line that's going to hopefully be as straight as possible. Obviously my idea of straight on here is not turning out perfectly. Okay, I need a point of intersection, and my point of intersection should be obvious in this case because I started at the same point twice. So my y-intercept here happens to also be my solution, and so my solution is to the right 0 and down 1. And if I test that, if I plug my x value into my x coordinate and my negative 1 value into the y coordinate, and I calculate that 0 minus 2 times negative 1, it gives me 2. And if I check here, 0 plus 3 times negative 1, it gives me negative 3. So I'm guaranteed that this is my final answer of 0, negative 1. Let's try 2 more examples. In these 2 examples, we're going to find that sometimes we don't get one solution. It's possible to get many or no solution. So we're going to take a look at those scenarios. For number 3, my first equation is not solved for y, so I'm going to solve it for y. And again, if you're confident, go ahead of me and then check your answer. I'm going to minus 2x and then divide by negative 3. And so for my one equation, I have y equals 2/3 x plus 1. For my other equation, I have 2/3 x minus 1, and I don't need to solve that because it's already solved for y. So let's take this first equation that we just solved for. I'm going to start up at 1, my y-intercept of 1, count up 2 into the right 3, up 2 into the right 3. I would continue that for as many times as possible and then reverse it, down 2 into the left 3, and connect these with the cutest little line you ever did see. And now I'm going to go and I'm going to do the same with the second equation. I'm going to change my color here. I'm going to do this one in blue. So y equals 2/3 x minus 1. So I'm going to start down 1, count up 2 into the right 3. And I notice I'm doing the exact same slope. So if I do the exact same slope, my lines would never intersect because they're increasing at the exact same rate. So that means that my lines will be parallel. Parallel lines have no solution. So if I have parallel lines, my final answer is to actually write no solution. There is no solution, no ordered pair that satisfies both equations at the same time, and that's because they never intersect. Example 4, my first equation is solved already for me, so I'm going to start by graphing that. Up 2, and then a slope of 4, so up 4 and over 1, up 4 and over 1, and then I'm going to reverse that, down 4 and to the left 1, down 4 and to the left 1, down 4 and to the left 1. Okay, I'm going to connect these with a line. I'm getting better. Okay. And for my second equation, again, I'm going to change colors. Okay. I need to solve this because y is not by itself. So I'm going to minus 8x from both sides. I get negative 2y equals negative 8x minus 4, and divide by negative 2, and y equals 4x plus 2. Well, y equals 4x plus 2 is the exact same equation that I was given in the first place. So if I go to graph this, I'm going to start at 2, and I'm going to count up 4 into the right 1, up 4 into the right 1, and then reverse it. I'm laying everything exactly on top of the same line that I already graphed. This means that I have only one line, but I have two lines that are exactly the same. That means they touch in infinitely many points. Okay, so the answer to this, my final answer, is that there are infinitely many solutions. This whole thing is my final answer, infinitely many solutions. So again, in summary, to graph, you want to always solve for y so that you get your equations in slope-intercept form. Start on the y-axis with your y-intercept, count your slope, and then draw both lines or graph both lines on the same coordinate plane. Identify the intersection if there is one and write it as an ordered pair. If there isn't, the lines are parallel and therefore there's no solution, or the lines are exactly the same and therefore it's infinitely many solutions.